I am very excited to be bringing another roundtable to our audience. This is Pump Station Design, What Operators Should Know. If you've seen any of our ads for this on LinkedIn, then you know it's also known as Pump and Up with Ott and Chris and Friends, because they want to pump you up, right? Yeah. So very excited to do something a little wild and crazy like this. And I want to start by running through our panel. So let me introduce everyone. First of all, I'm Christine Gonzalez, Senior Project Manager. And let me get it. And Storage Tank Queen. See, I'll wear a costume at Entech Engineering. My colleague, Chris Hannum, he's a principal at Entech and has 30 years of experience in water and wastewater. Dale Miller, as Chris had mentioned, he actually personifies Entech's longtime focus on operators and when helping our clients. And he's been with Entech for 3 years as an operations specialist, but also has 27 years of operations experience. Also with Entech, he's a first-time panelist on our roundtable is Rich Harrison. And Rich, I forget, what is your title here?
Senior Project Manager.
Oh, do you know what? That's what I had. Okay. And you're out of our mountaintop office, right?
Correct.
And how long have you been in the industry?
Oh, over 35 years.
Okay, cool. So lots of good experience on this panel, because wait till you hear about the next two guys. We love these panels because we also bring our outside friends and resources, people we trust. So we invited Art Achenbach, who's president of Riordan Materials Corporation. He's got 26 years under his belt. And we've got Bob Kunzelman. He's been around for 47 years as a salesperson with and he's currently with JT Sealy. So one of the things I asked Dale to help us out with, and this is, my background is tanks. I know nothing about pump stations, so I'm maybe learning some stuff with the rest of you guys out there. One of the things I wanted Dale to help us out with is sort of explaining these pump stations, what are the different components of it? So we've got a wet well, we've got a dry well. I hear wet wells, sort of this design is what you'd see 80% of the time. It's the workhorse. And just to give you an idea, flow through the section view on the left, it would go in the one side and out the other side. But Dale, you want to hit on a couple of the key components that you see in this wet well?
Yeah, sure. This is basically a submersible pump station. The pump, of course, is in the wet well. So you see it in there. And like I say, you see the pump, and it comes out of the pump, comes up and out of there. And then oh, okay, I thought that was a valve pit. There's usually another pit, a valve pit, which would have check valves and things like that, and a control panel up top. And you can see the lid on top of the pump station. And usually there's something there to remove the pumps if you have to take them out. Like I said, this is a wet well type with submersible pumps. There are other types. I think Christine has another slide here that shows a dry well.
And one thing I noticed Dale, when I look at the plan view, it looks like there's 2 pumps in here. Is that normal? Do you normally have 2, or what's the deal?
Yep, there's normally 2 or more. There can be 3 or 4 depending on the situation. But if the pump stations are usually designed that one pump can handle the flow, the second pump is not there to pump more. It's there as a backup for the other pump. So
that's a state requirement.
Yeah, that you have to have.
Got it. Okay.
2.
Yep. So there's a wet well, and then here's the dry well. Tell us about this.
Yeah, this is just a different type of pump station that it still has a wet well on the left there, but the pumps are not in the wet well. The pumps are to the right, which is actually basically the basement of that building. The suction from the pumps goes into the wet well, but the pumps are not in the wet well. They're in the dry side. That's why it's called a dry well, wet well situation. Usually sometimes has a pump motor that is up top, and then there's a drive shaft that runs down to run the pump. Or a lot of new stations now, they put a submersible pump in the dry well, just in case you have a flood or something like that. The pumps are put in there. They could be put in the wet well, but they're put in the dry well side. And sometimes they do that as a safety feature in case you would have a flood. It wouldn't affect the pump. Everything works basically the same. Usually in the dry well situation like this, the check valve and so forth is in the dry well side there. Actually, it shows the check valve and isolation valve up at the top.
Okay, excellent. Thank you.
And
so I'm hoping our audience Most of you probably know this, but it's just good to refresh your memory as to what we'll be talking about today and the different components. So I mentioned these roundtables, they're all about you, our audience. So I'm going to send a poll out right now. We want to hear from you. We want to find out what you want to know. So essentially, what do you want to understand about pump station design? So it's multiple choice, and got 6 different topics here. So pick as many as you like. And what this does is it helps us to focus on what's important to you guys, because these guys could talk all afternoon about this. We've only got 75 minutes. I want to try to focus on what's most important and of most interest to you guys. I'd mentioned we'll probably end up doing another one of these. This one's more on the operator side, what operators want to know and understand. And we'll probably do one on the engineering side, what engineers need to understand when it comes to designing these. So I'll give you another 5 seconds and we'll end the polling. Looks like we've got most of the people who submitted answers so far. And once again, you can submit as many as you want. Okay, I'm gonna end the polling right now and I'll share the results with everybody. So it looks like number 1 was the important elements that engineers and owners miss during the design process. Okay, important elements. And then picking the right pump, and is a VFD a good choice? And then what's normally addressed during the design process. Okay, cool. That's very, very helpful. So I appreciate your feedback, everybody. And so my panel, let's get started. That first question, important elements that engineers and owners missed during the design process. So already it looks like our audience wants to hear your horror stories. So does anyone want to be, pretend I'm Oprah, confide in me, no one else is out there. Anyone want to share, or perhaps a different engineer had a struggle? What things have you seen out there? Rich, it looks like you're dying to tell us a story.
Yeah. Probably the biggest problem that I've seen with pump station design is actually the force main and having high points that don't need to be there, or pumping downhill. I've had a lot of, not to pick on developers, engineers, but a lot of people who think, let's just pump downhill, and that's problematic. So it's more the hydraulics in the force main, and putting in air release valves, which, and the operators could attest to, almost never get maintained, but they're put in for a reason. So that's probably the 2 biggest things I see.
Mm-hmm. Okay. Dale?
I've experienced some that I think the pump manufacturers and the engineer need to understand, especially in a submersible pump station, where you have to lower the pump down through a door on the top of the pump station. The door on the top of that pump station has to be big enough for the pump to fit through it. I have seen situations where that has not been the case. And I've seen rail systems, instead of going like this, go like this in order to get the pump into the top of the pump station. Just sharing that little bit there.
Just
Anyone else? Go ahead.
Little things.
Little things,
Bob.
A clear definition of how the pump stations are going to operate. A lot of times, especially with VFDs, we do not know anything other than what a rated point is, and we don't know if that's the maximum design flow for the pump station. If so, what is the minimum flow? Where do you expect to operate most of the time? Just seeing a specification with a design flow doesn't tell me how you're going to operate the station, whether it be a submersible station or a dry well, wet well, or a self-priming station. So I want to see more data on how you're going to operate the pump, what the owner needs, especially when you're designing for the future, which may be 20 years from now, but you're putting in an oversized pump right now to handle that. But right now you maybe need half that flow or a quarter, or even less. So something more than simply flow and head.
Mm-hmm. Okay. Art?
Yeah, to tag on what Bob said, a lot of times, as the vendors, we get just a flow in ahead, and you're okay, and you just make a selection and give that to the engineer. And a little bit deeper dive into how the station is going to operate, because the reality is there could be better ways to handle this introductory flow. And this is especially true for developer type jobs or where you're planning for 20 years down the road. We might be able to offer a smaller, more efficient solution now that could be upgraded in the future to higher horsepower, different impellers, things like that. So if we know, if we could, know upfront exactly what you're looking to accomplish from a flow perspective, and not just a flow and a TDH, but also a flow and a TDH and a static head, maybe look at your system curves. So then we can help give you a pump selection that will be best suited for the scenario that you're faced with. Along with that, I think you also have to look at, and Entech, of course, doesn't do this, but on occasion we'll see projects where, hey, it's a round 6-foot diameter wet well, and there's pumps in there, and that's all that's shown. And operators know rags, debris, fats, oils, greases all become problematic. So how you lay out that wet well, and this is more applicable to obviously a submersible station, how you lay out your wet well significantly impacts how that station is going to operate. If you have your influent pipe coming in and not having it drop down below the surface and just cascading in, that could be a problem for the pumps. If you don't fillet your corners and kind of chamfer them to direct all of the solids and things in there to the pumps, you're going to get stagnant areas. You're going to get things floating and odors. So one thing leads to another. So a lot of those details need to be addressed. Obviously, it's nice to have a standard design. We all wish we could do our standard. I think we all know in this industry, there's no such thing as a standard. So it's important to look at every pump station as its own entity.
Yeah, Chris?
Besides all the hydraulic information here, which is all good, the part I think most engineers forget about or pass on is, okay, very proud, I got the hydraulics, I did the layout. And this goes to the operator's part, they have a tendency not to think about the layout of the whole how everything is going to work together. Is there an outlet outside that I can take and plug tools in because I have to work? Is there something overhead that's going to give me protection from the elements when I'm opening a panel? Did somebody have the panel facing towards the direct sunlight so that I've got to literally cut my hands over? It's those little things that make the operator's job just that much tougher, and that we try to avoid by having somebody look at the layout and go, yeah, that's great, Skippy, but how are you going to get just what Dale said, that's great, Skippy, but how are you going to get those pumps out? And am I going to be able to back a truck up and put them on the back of the truck so that I can get them to a repair center, those type of things. So I'm grateful we have guys like Dale that when we hand them something with a red pencil, go, okay, what did I miss? These type of things get picked up.
So a comment we have from our audience was that engineers know that smaller is cheaper, but operators and maintainers know that more space to work in is better, even though it's more expensive. And plus, some of us aren't as small as we used to be. Ale, the example we had shown of that wet well was a 6-foot diameter one. When it comes to size, layout, what sort of things do you look for on the operator side? What's helpful for them?
Well, I hate to say it, size matters. If the wet well's a little bit larger, but again, then it can't be too large, because if the wet well's too large and you have low flows at the beginning of your system, if it's a new system, whatever, then you're going to have settled material, like Art said. You're going to have odors. You're going to have all kinds of crazy things going on. So there's a lot of things that you just got to try to balance. And to go back to what they were saying, Art said about possibly putting in a smaller pump from the start or something like that. The first wastewater treatment plant I worked at, they had the last pump station, every pump station pumped to the next pump station. So we had 7 pump stations in a row. The last pump station had 100 horsepower pumps on, and the flow at our treatment plant was about 80,000 gallons a day. Those pumps would run for about 30 seconds. Well, I shouldn't say that, for about 10 seconds. They would kick on, suck the well down, and shut off. That was it. And, that's no good. And then you would have deposits in the wet well, then you would have odors, then you would have all kinds of situations. So there's just, the size of the wet well is very important, and layout is important, but there's a lot of things to consider. Everybody says, well, just put a twice the size. Well, that's not always the answer. You know, there's types of wet wells you can put now that they make that actually clean themselves, and there's things you can put in the with the pumps that actually stir up when they pump, so it moves things out of the wet well. So there's a lot of things out there, but there's a lot of tough decisions to make when you're deciding on designing these things.
So it's almost like there's not one right answer. There's lots of answers and repercussions from whichever direction you take. It's just a matter of working with people who can help you through the lifespan of your system, right? Chris.
The biggest thing, and Dale's hit upon it, is, you know, you design a pump station for year 20, but it's got to operate year 1. You know, you can look at decreasing, you know, picking the smallest impeller in a series of impeller families. You can look at VFDs, you can look at all this stuff. But as long as the requirements are that you've got to hit that 20-year mark, one, it's difficult to get, you know, a phased Part 2 permit that we're going to put these pumps in, and then 10 years from now, we're going to put the bigger pumps in that we really need. Plus, there's something about taking that type of scenario to an owner going, here's 3 stages of construction spread over the next 20 years. You're on board for paying all this because it makes my life easier and makes your operator's life easier. I haven't tried to sell one that way, but.
Okay. Art?
Well, it's kind of tagging on to what Dale and Chris mentioned about managing that wet well environment. And one of the questions was about, you know, having grinders put in versus types of impellers. And again, that's all factors that go into a pump station design. You know, again, speaking on wastewater submersible pump stations or dry pit submersible pump stations, 99% of the time you're going to have what's called a non-clog or solids handling impeller, and each manufacturer has their own versions and tricks and things they do to the impellers and types of impellers, but most of those impellers are going to be pretty standard across the board. The big problem now, of course, is the wipes and things like that. Grinders help, and then it gets into how you operate your pump station. If you're, like Dale said, if you're only operating once a day and you're allowing all that flow to come in, get ground up, and it settles to the bottom and just happens to sit right below the bottom of that non-clog impeller, as soon as you turn that thing on full speed, you get a big rag ball that might be sucked up into your volute. So that, combined with full speed versus half speed with VFDs, a variety of factors can create little raggers. You grind it, you get a slow moving impeller. It's like your washing machine. It's just going to turn down there and you're going to get a little ball that grows and grows and grows. So you want to make sure in the control or the O&M of your pump station, every once in a while, hey, you go through what's called a cleaning cycle. A lot of manufacturers have that built into the controls. It's mindless. It automatically happens. But if you don't manage that environment, doesn't matter if you screen it, you grind it, or if you do nothing, if you don't manage that environment, you're always going to have problems.
Okay. Yeah, go ahead, Chris.
I see Entech's pump station design, so I'm very familiar with that and the trends that are occurring there. But for Bob and Art, you guys see ours and our competitors. Are you seeing more grinders included in the pump stations?
Yeah.
And Art or Bob?
Yeah, Chris, I don't know if we're seeing more. I think they're there on a consistent basis. And as Art says, different manufacturers have different styles of impellers that can help in taking care of the fog that we're seeing more and more these days. Again, it comes down to a definition of what you have to take care of now and what you have to take care of in the future. As everyone has said, we're also seeing some failures of the grinders. They're being overwhelmed with what's coming through there. And so they're not doing the job that is expected in the design phase, such that the pump is having to do more. And that might induce somebody to specify a specific type of impeller, whether it be a cutter type, what Flight's got, rather than the enclosed impellers that have been the mainstay of the industry for a long time. The vortex, the recessed impeller, is another way of doing it. So there are different things that we can apply, getting a better handle on what is coming down the line into that pump station. Is it strictly residential, or is it a combination of industrial, commercial? The other thing we see is that some of the controls are set up to maintain a constant level in the wet well. That sounds like a great idea, especially if downstream what you're pumping to can't handle a batch type situation. The trouble is that's also conducive to setting up a grease blanket in the wet well. And when, as Art suggested, you go through a maintenance cycle, to get rid of that can be devastating. So there are lots of things that need to be considered. And again, in my opinion, it comes down to what are you trying to do, and as much information that can be shared with the engineer, with the pump manufacturers, the controls manufacturers is the best way of doing it.
Art, do you have anything to add?
No, I was just adding that, yeah, so the comment about grinders, we do see it probably 50% of the time, because inevitably you have engineers and operators that are either grinders or screeners, and rarely do you have both. And so you do see more larger pump stations now with screens. That obviously creates a whole different set of operational maintenance issues for an operations staff. But based on the size of the municipality and the staff and what they have, that might be your best option. A grinder isn't going to hurt the pump station. It will obviously help the pumps. The problem with a lot of grinders is they're shredders. So all they're doing is taking a big rag and turning it into a bunch of little tiny fibrous rags that very easily get themselves knit back up again. So again, going back to managing the wet well environments, how you handle those rags, how quickly you get them out. Like Bob said, if you're maintaining a constant level, it's amazing how quickly that scum layer, and this is right after lunch, so probably not the best topic, but it can get thick and nasty. And if you don't manage it, if you don't have the ability to pump your pump station down to what we might call a snore cycle, basically cavitate the pump to suck everything out of there, you're going to have problems. So you have to incorporate, if you're grinding, how are you getting the tiny debris and rags out? Don't just let it flow match, pump it down, get it out, send it where it needs to go.
Now, Rich, I'm wondering on the design side, how do you decide when you put a grinder in and when you don't?
Usually most clients have preferences, whether they want grinders, shredders, choppers. So you got to listen to the client first. Generally, the grinders and choppers are an issue in the smaller sizes, the 4-inch. When you get into the bigger sizes, the pumps can handle solids, so it's not quite as critical when you're dealing with like 6, 8, 10-inch pumps. But what I've been doing recently, because I think the jury's still out on some of these disposables. I mean, when you look at wipes, yeah, we've had wipes for a long time, but now there's, disposable diapers and all this other stuff that gets, I hate to say it, but it all gets flushed down the toilet. I'm dealing with a retirement community, and it's just a real major issue. So we're putting in, like on my design, I'm putting in provisions to add a future grinder, even with a chopper pump, okay? And we just put the rail system in, the hatches, and just to keep DEP happy, we put a screen in because they want a standby screen. So we tell the operators, try your chopper pump out of your grinder pump and see how well it works before you go to the screen or go out and buy a $20,000 or $30,000 grinder. So it's based on what happens over time. And these chopper pumps, I don't know what the wear life is on them. If they're going to last if they need to be rebuilt every year, or if they last 5 or 6 years. So the jury's out.
And part of it, wouldn't it depend on how much it is used? Like the more
Correct.
you use it, not like every single day. Yeah, Art.
And I will say we do see more people ask about, oh, I want to put a chopper pump in my wet well. And the reality is chopper pumps weren't necessarily designed for municipal wastewater. Okay, they were designed for high solids applications like digesters, things like that. Not saying they don't work, but a chopper pump will have problems, will be less efficient. It would not be, most submersible pump suppliers would not recommend the chopper pump as your first option. Look at your solids handling pump, even for Rich, the cases like nursing homes where you are getting high solids in, because chopper pumps are a heck of a lot more O&M over the life cycle of a pump station.
Okay, Dale, you had a comment?
Forgot what I was going to say. No, I was going back to the to Art's comment about screens, and I'm a believer that, and it's just my personal belief, don't chop it up, just get it out. But when
Yeah.
you're talking about a pump station, you got to remember that that pump station is not at the treatment plant usually. It's usually out in the, so if you put in a screen, and again, not all screens, but most screens need wash water. So now you have to either drill a well or connect your local potable water supply to run that screen. I just was talking to a gentleman yesterday that they put a screen in their pump station. It's doing a great job. They love the thing, except their water bill is $1,500 a month because they're using potable water to wash the screen. It's working like a champ, but it's now costing them $1,500 a month. So, I mean, it's just more things that you have to consider. Yeah, I want a screen. Well, okay, you got to have the electric for it. You got to have the wash water for it. You have to have a place to dispose of the rags. You know, it's not as easy as just saying, I want it and put it in there. There's a lot that goes into that. So.
Do you guys ever go to Target and when you're walking down that cleaning aisle and you see the disposable wipes, do you ever take a sticky tab and write not and put not disposable, not? If we all do it, then people will learn. Like I'm constantly telling my friends, they're not. I'm doing what I can. Chris?
I think they're here to stay. Sorry. No, but the advent of vertical screens, you know, before it was the basically either something you mounted inside the wet well or something that was pitched on a 38 degree. Now with the advent of the, not advent, I guess they've been around for at least a decade or more, the vertical screens, are those impacting, and I'll throw this to Bob and to Art. We've installed it. Half a dozen. They seem to work. Operators seem to prefer them. And like Dale said, why deal with the problem twice? Because again, even if you pump it, it gets to the wastewater treatment plant. It gets through that system. Now, whatever biological reactor you're dealing with, now you have the reknitting going on there. I don't know. More vertical screens, Art or Bob?
You do see them. They're becoming more prevalent, but again, like Dale said, that's another item that mechanical operation, freezing weather, snow, you know, so you get heat tracing,
odor,
potable water. Yep, odor, because the stuff being screened out, it's such a great screen. It removes everything, and by everything I mean everything. So it does it. Now you say, okay, well, I have the screen. Well, then I need to build a building around it to contain the odor. Oh, now we're getting into explosion proof, and all of a sudden your little issue of getting some rags out becomes the pumps are inconsequential in the scope of this station. And Ed Petrosky hit the nail on the head. You have a postage stamp size lot to work with. You don't always have the luxury of building in all of those. Obviously, if you have water on site and you have an authority maybe that controls the water bill for the wastewater side, then it doesn't become an issue on the wash water. So yeah, we do see screens a lot. Speaking for myself, and maybe I speak for Bob, I think most of the large pump stations is where you'll see screens. Your standard 4-inch, 6-inch pump, you're typically not. More often than not, it's going to be a grinder. Maybe if you're lucky, you'll have some type of wet well mixing system put in there, but that's pretty much it.
So if someone poses the question, okay, which is better, screens or grinders? Is the answer it depends?
It depends.
Yeah.
Depends.
Okay,
Definitely
Mike
maybe.
Dashball, I hope that answers your question. Rich?
At a treatment plant, I agree with Dale. I prefer screens at a treatment plant where you get dispose of everything. But it also depends on the size of the treatment plant. Like you can't put grinders on some of these small treatment plants that have like airlift pumps and stuff like that. So you do have to take stuff out at certain types of treatment plants because it's just not optional to try to get it through downstream processes.
Okay, want to relay what was that, Bob?
One of the common threads of all the conversation here was maintenance. And every time you add something, that's something else that has to be maintained. Art was talking about our chopper pumps, totally suitable for the application. Grinder pumps with wear rings, screens, mechanical screens versus a bar rack. There's one customer I've got, they don't believe in any screens. That pump has got to pass whatever's coming down the line regardless. And that's a challenge. And so they've gone to the single vane impeller, they've gone to the vortex type impeller, because they do not want clogging of any way, shape, or form, because they have no protection up front. But again, it comes down to maintenance. Every time you add something, someone's got to maintain it. And as I think Chris said earlier on, it's going to break at 2:30 in the morning on January 1st during a snowstorm.
And
Yes,
just because you have screens and just because you have grinders doesn't mean things don't. As North Coventry, the operator there showed me a cue ball that they pulled out of, and they have line after line of defense, screen, grinders at the pump station. So how a cue ball got all the way from somewhere in North Coventry into the influent, but as soon as they would turn the pump off, they could hear the cue ball running around the volute of the pump. So they knew that they had an issue, opened it up and pulled out the cue ball. So.
Oh my God, Dale?
To Bob's point about chopper pumps and so forth, chopper pumps are they're a great item, but just like your kitchen knife, when you use your kitchen knife and you use it over and over and over again, what happens to it? It gets dull. You got to sharpen it. Well, they got to pull that pump out of there. You got to replace that cutter blade. You got to sharpen the cutter blade. So, I mean, just because you put that, chopper pump in isn't going to save you forever. Eventually, it's got to be worked on. Again, as you said, as you add things, it's more maintenance that you have to look at down the road.
Back to some questions from our audience. A reminder to the audience, we're taking questions from you guys. We want to know what's important to you. So use the Q&A button, keep submitting them. We'll keep addressing them. Anthony Lewis poses the question, what are your thoughts on pump station to pump station flows? I don't know what that means. Does anyone can anyone explain it? Dale, and what is it and what are your thoughts?
I believe what he's references to is sort of what I said in the beginning, that you build a pump station way out yonder, then you build one a little closer and a little closer. So all they do, the first one pumps to the second one, the second one pumps to the third one, the third one pumps to the fourth one pumps to the fifth one. I am not a fan, but if it all depends on the topography of the area. Sometimes you have no choice. If you have a really long area out here and you have a development out here and you have one a little closer, it is very common, at least what I have seen. Again, I don't like it because I think as the system I stated that I started at, we had a pump station that was very far away and it did that. And we did a test one time. It took 4 days for that flow from the first pump station to get to the treatment plant until the pump.
What's ideal? I'm assuming shorter?
Less than 4 days.
Yeah, less than 4 days. And that's why we ended up spending a lot of money on odor control, because that stuff's 4 days old out there, and then it's getting pumped to the next wet well and spilling out into the wet well, and all the nice odors are wafting out, and then it goes to the next one and the next one. So
this is why most collection systems follow streams.
Yep.
Okay, Art?
So one of the modern advents, I'd say probably more prevalent in the last 20 years would be, the introduction of SCADA systems to a lot of municipalities. And that has really, those municipalities that have a lot of pump stations, SCADA control really has enhanced their ability to operate those systems. So they can have a predetermined amount of time that a pump station, even though it might only be a quarter full, they might say, hey, that thing's going to pump once a day, regardless. The SCADA system makes it maybe short cycle, if that's the correct term. So that's just another tool in the operator toolbox. As you start to talk about SCADA, it's more than just monitoring what's running, number of hours, but you can really start to introduce some asset management into your pump stations. So if you're an authority with a lot of pump stations, you can look at your hours, and that could be an indicator. Okay, I got to run out there, take a look. You can also dictate, like Dale said, how many times a day a station may or may not run. Like I said, you may want to get that stuff out to prevent odors and fats, oil, grease buildup. Every day we're pumping down, getting it out of there.
Okay. Yes, go ahead, Bob.
The other thing about what Art said is having a pump sit there idle for a long period of time creates its own problem besides the accumulation of crap in the wet well. I worked on a pump station that had 5 pumps, 3 of them max operation, 2 installed spares, 1 normally operated. They went into a normal alternation cycle of about once every 6 to 12 hours. We found out that that allowed the pumps to go airbound or gasbound, whatever you want to call it. The alternation cycle went down to every hour a pump changed. Otherwise, they went gasbound on the things. That's where a sophisticated control system comes in handy. As Art suggested, you can run the pumps. Not only is it alternating on cycle, it's alternating on time in order to keep the pumps, the wet wells clean and the pumps from going gasbound.
Okay, interesting point. Thank you. Comment from the audience. Craig Conrad shares, is not a question, but we have found adding a standpipe and valve to allow bypass pumping is a very good idea. It beats running 1,000 feet of hose to your nearest gravity manhole. Dale?
Absolutely. That's something that I think, somebody thought of not long ago, which should have been thought of long ago. And you see it at most pump stations, and that is like one of the greatest ideas that I've seen. It's ready in case you need it, and you have. Mostly, if you're putting in a bunch of pump stations, you get a spec. You have a pump that can do what you need to do, that you can hook to that in an emergency situation. I think that's one of the better ideas I've seen in pump station design.
Cool. Art?
Yeah, we see a lot of pump station design now where that is integrated into the design, whether it's a suction pipe from the wet well into the valve vault. A lot of municipalities, larger municipalities, have their own, Godwin, for lack of a better term, backup pump that they could take out to pump down, and you can just tie it right back into your force main. We do see a lot of designs now, instead of just a big generator, people are putting in complete redundant backup suction lift pumps. If you lose power, a diesel powered pump as backup. So we see a lot of municipalities, especially those with a lot of I&I or electrical issues, entertaining that thought, because even if you have a generator, but your VFD and your control panel is blown out, you're not going to be able to pump anything. So having that complete redundancy is something we're seeing a lot in a lot of designs.
Okay. We got another really good question from the audience. Thank you so much, Zach Martin. I miss you with Aqua. He says, is there a change generally in the industry towards the reduction in size of the wet wells? He says, traditionally, wet wells were large, allowing time to react to pump failures or wet weather flows, deep pits that allowed for some EQ at times. But it seems like now they're getting smaller and more dependent upon zero failure. He knows there's pros and cons to both, but I'm curious, what are the thoughts of the panel? Chris?
First time we started to see the change in wet well sizes when VFD showed up. Because of that constant pumping, your wet wells got smaller. Owners liked it because you poured less concrete. Yeah, they are, I agree with them. The trend is to try to get them as small as possible. Again, that was probably more spurred on by VFDs and how many starts. Typically, it's how many starts per hour a vendor will recommend really sets your wet well volume.
Okay, Art?
Tagging on to what Chris said, you have a variety of factors. So yes, the wet wells are getting smaller, but you also want to maintain that environment. You'll hear me say that all the time. So having a smaller wet well volume isn't always done just to make it smaller to save money. It's also just to help size so that pump station runs more efficiently. Chris hit the nail on the head. Most pump manufacturers, their motors can handle 20 to 25 starts per hour. So that start stop, well, historically that was like a no. It's not a problem anymore. Additionally, most pumps can pump down. So instead of keeping that motor completely submerged all the time, if it's a larger pump with, say, an 18-inch, 24-inch high motor, you can run that motor exposed. So now that's additional volume that you maybe didn't have before that you can use to, again, further decrease that wet well volume. That design for wet well volume is a constant battle. I want EQ because I'm afraid of the wet weather flow versus turning the pumps on and off. And that's something as an operator, you are going to be the best person to tell your engineer, here's what I see. Here's the 2 a.m. call I am getting. Here's the backup pump I don't have to help me get over that hump. So that's when your engineer asks you for your flow data and your only answer is, well, my flow meter is pegged at 60. Okay, let's do a little bit more research. Allow your engineer to study with you a little bit more on what that flow rate is, because the last thing any of us want to do is put in a new pump station and the first rainstorm it overflows because the pumps can't keep up with it.
Have any of you ever seen that happen?
Never on an Entech design.
Or
Oh, I've seen more. I've seen more the other end where the design engineer sleeps really well at night because they've got these huge pumps in there, and if you're gonna err, you don't want to err on the side of my wet well overflowed. Not on day one.
Got it.
The other issue is that you've got to consider if there's a future condition we talked about, that you're designing for something that's small now and it's got to handle large flows in the future. The wet well size for the future, unless they want to build another wet well, which is probably unlikely, is oversized for now. And instead of getting the condition, we have certain instances where the wet well is undersized and it can barely handle this upsized flow that has been accumulating over the last 20 years. And then, especially as the pump sizes get larger, you have a lousy intake arrangement and the water going to the pumps is not ideal, and you create problems there with vibration, et cetera, vortices, and that can wreak havoc, especially as the pump sizes get larger.
Another question from our audience, or a comment, Eric Moore from Entech. He says, don't forget to consider odor control in your pump station if you're in a populated area. Rich, how do you normally handle something like that?
The last two projects I worked on were in very expensive neighborhoods, and one was at a cul-de-sac with $500,000 homes around it. So odor was a really major issue. We just put a carbon scrubber on the vent pipe. We basically had like a below ground vent pipe that went to a drum scrubber. It's basically just a drum filled with carbon, and you have a fan that runs continuously. It's relatively inexpensive and low maintenance. And they'd only run it during the summer when people were out and about. In the wintertime, they generally will turn it off because most people aren't bothered by odors and they have their windows shut and they don't have fans pulling ventilation through their building. But that's relatively inexpensive. Now, if you have a long force main pumping to the pump station, then you probably need to look at chemical feed at the pump station to prevent the odors from forming in the force main. That's really another issue.
Okay, Art?
What Rich said, because that's usually your biggest issue is the discharge manhole. It's not the pump station itself rarely is the culprit. It's where it's discharging, 1,000 feet away. So, keep that in mind. There's ways to handle that. You might go to a manhole where you can't put, because it's the middle of a highway or middle of a road and you can't put odor control. There are methods, chem feed, things like that you can do at the pump station to allow those chemicals to react while it's in the force main before it discharges outside of that multi-million-dollar home.
Okay, excellent. Well, we're going to play a game right now. My panel doesn't know this is coming, although if they've been on my panel before, they may have suspected they'll be seeing something like this. So we're going to play Sewer System Survivor. So today's trivia question, and please don't use the internet, but where and when were the first sewer systems built in the United States? So I'll start with you, Dale. Dale, what's your guess?
My
guess
would be New York City.
New York City. Any time? Do you have a time frame? Any sense of that?
Oh, geez. 1890s.
1890s. Okay. Art, what about you? What do you think?
Ooh, I don't want to overbid, like Price is Right.
Yeah.
I'm with Dale. I'm going to say New York City, but I'll say early 1900s.
1900s. Okay, excellent. And you know what, audience? I want to hear from you guys as well. What do you think? So this will actually help the panel out a little bit, but panel, think what your answer is right now and don't look at the screen. So want to release another poll for sewer system survivor. And my audience, we've got 5 different options here, but continuing with my panel, Rich, what's your guess as far as where and when?
I just looked at the panel. Sorry about that. I would say probably New York City also.
Okay, any sense on the time frame?
Probably the 1850s.
1850s. Chris, what do you think?
I'll go with Rich.
You like Rich's? Okay. And Bob, what do you think?
I don't think it's New York. I thought it was somewhere away from New York, but Philly or Boston.
Philly or Boston. And a time frame?
Mid-1800s.
Okay. So as far as the polling goes, let's see, share results. Looks like our audience, they were guessing both Boston and Philadelphia, but the true answer was, share my screen again, Chicago and Brooklyn in the late 1850s. So this is actually a drawing of Chicago in the 1860s, but if you go on Wikipedia, it's Chicago and Brooklyn. So anyone who guessed New York City, you were right in the right ballpark there. And so I know it was Bob and Rich. They were both guessing 1950s, or I'm sorry, 1850s. Nice work, gentlemen. You guys will be rescued from the sewer. Yay! The rest of you have to stay there till our next roundtable. Yes, Dale.
Can I share one interesting fact I found out when I was in Chicago for WEFTech a few years ago? We took the tour out out in the Great Lake there, and I found out, and again, I apologize, I don't know what year it was, but do you realize that Chicago reversed the flow of the river where it comes into the Great Lake to go the other way? So the waste went down the middle of the country instead of out into their Great Lake. You think they'd be able to do that today?
Only if you don't get caught.
That's just a general permit, right? You're good.
That's right. Very general.
Okay, so thanks, guys.
It was not that.
What's that, Bob?
Dale, it was not that long ago. I was at Alice Chalmers, and the Gowanus Canal in New York City and Brooklyn had a pump that went back into the original drawings were white pen on ink. Think about that for a moment. They were actually gorgeous. And there was a pump there. It was rated about 1,000 CFS, 440,000 gallons a minute, and it could pump either direction. And so what you described for Chicago was what they were still doing in New York. I've been out of Alice Chalmers since 88, I think, 84. And so, yeah, they were doing that in the Gowanus Canal. The Dutch, when they came over to the States, the first thing they did was reclaimed land, which they had 3,000 miles to work with, but they reclaimed land. And they built this canal, and it was supposed to pump water in both directions. And they redid the pumps. But the first thing they forgot is when they drained it, who was going to take care of the contamination that was there? And so they had to rebid it several years later.
Interesting. Okay, so heading back to our audience, reminder, use the Q&A button and submit any of your questions. We still have a bunch to go through. So Anthony Lewis is curious, have you guys seen issues with all the low flow water faucets, showers, and any problems because of less flow in the pump stations? So what have you guys been seeing there?
I've seen more problems at the plant with higher organic loading over the years than I've seen it at wastewater treatment plants. We used to design around 200 to 210 BOD. We're seeing routinely now 300 plus. So that's the problem I'm seeing.
Okay.
Much low flow.
Any other comments on that? Okay. Yes, Bob.
You're seeing more of that at the pump stations. the concentration is higher than it used to be for the traditional definition of wastewater. And that brought up the new line of pumps that we had been talking about, the choppers, the grinders, the vortex pumps, instead of the traditional 2-vane non-clogs that we used to have. So yeah, I see it at the pump stations.
Okay. Okay, another question from our audience. This is from one of Entech's new employees, Chuck Sakonis. He says, address sewer corrosion due to anaerobic decomposition over long transit times. Can you comment on the materials of construction for the pump station, pumps and piping, and what will, I guess, fight that deterioration? Art?
I mean, as a pump vendor, I'm not a pipe vendor, so I'll defer to others on the pipe material. But a lot of times we see in pump stations a lot of these epoxy coatings on the insides of the wet well. That appears to work pretty well. If there is concerns for the pumps themselves, you can get, there's always different coatings, aftermarket type coatings you can get, but I've never seen anything as a quote standard municipal wet well where that's an issue. Where you might have issues is if you have an industrial component to the wastewater, so high temperatures, things like that, that's more problematic for the type of seal material maybe that you're using. But other than that, there really hasn't been too much that's not pH related that would be a problem for the pumps.
Okay, Chris?
Actually, Christine, as you've entered in our world with coating some of our tanks, you've seen the issues that we've had. Maybe things have changed in the last couple of years, but I've always had a very difficult time of getting a coating manufacturer to give you any type of, I won't call it guarantee, but any type of promise that this will last 5 years in a wastewater environment. I don't know if Rich has done a lot more wet well design than I have, so I don't know if he's found it similar or not.
Yeah, Rich, what are you seeing?
It depends on the severity of the intended corrosion. Like if it's like a pump station that's taking discharge from a force main that has high H2S levels, and you're going to have really bad H2S. I've gone so far as to put T-lock lined or Agru Sure Grip lining, which is like HDPE sheet lining. And for like a circular manhole, circular pump station, that's not that difficult because the precasters actually put the lining in their forms before they pour the concrete, and it's bound into the inside lining, and you can get different thicknesses and things like that. And I've done that for drop structures, but and then there's there's coatings, but I've used the T-lock lining or Agru Sure Grip has something similar.
Rich, have you ever found any of the coating manufacturers, especially in wet wells, I won't say they will stand behind their product, but stand behind their product?
Not really, because it all comes down to surface prep, and they have no control over what's, the contractor's installation. I've had better luck with like somebody like Tnemic, who's actually, when they have the opportunity to watch and certify, well, when you make them certify that it's properly surface prep, and they have a chance to inspect it, then you can get a little bit out of them. But you're right, I haven't seen anybody make any long-term commitment on coatings or linings.
Any other comments on that? Dale?
Another consideration, which we touched on earlier, is the corrosion doesn't always happen in the pump station. It happens at that discharge manhole. And now, today, again, I have no experience with this, but I see there are now composite manholes instead of concrete and things like that I think are a great choice if you're running 1,000-foot force main somewhere and you're going to be discharging. And if it's a 1,000-foot force main, there's going to be nasty stuff coming out the end of that. But I guess then the other thing is, how many manholes do you go downstream and make them composite like that? But, I don't know if anybody has experience with the composite manholes or anything like that, just bringing that up.
Yeah, because actually Bob Kearns poses or any experience with HDPE or plastic wet wells. Is that sort of what you're talking about, Dale?
Yeah, sort of. And that's what Rich was touching on too, about the lining that they put, if they precast a circular section, they can put that right in the mold. And I think that's an awesome idea. I didn't even know anyone did that. That's really interesting.
Yeah. Yeah, Art?
And again, I'll defer to more to the concrete folks, but there's admixes like Rich mentioned. You can get fiberglass or HDPE wet wells, typically for smaller pump stations. So the entire wet well is a fiberglass tube basically. You also can get for some of the tank for the wet well coverings, the caps, polymer concretes that are they won't corrode. So there's ways to handle that. Most of it's probably on the concrete guy and the coatings folks to answer, but there are some small steps that pump suppliers have access to help with some of that.
Any other comments on that? Yes, Rich?
When I was at Scranton, we were using HDPE pipe for storage, for CSO storage, and it was pressure rated HDPE, but we knew corrosion could be a problem because stuff could sit in there for a day or two. So we went with HDPE pressure pipe.
Okay. Another question from our audience. Any thoughts about grit removal?
Do it. Get rid of it. Remove it.
Okay, next question.
That was easy.
Yes, Rich.
I like to remove the grit ahead of a pump station if possible, because you have two choices. You either remove it from the pump station wet well, or you probably remove it from the force main. However, one of the things I've been doing on recent designs is try to get up to scour velocity on a larger force main, which is 3.5 to 4 feet per second, because pumps that cycle on and off, when DEP says 2 feet per second, you got to maintain that. Well, when you turn the pump off, the stuff settles and it takes about 3.5 to 4 feet per second to resuspend that. So I haven't had any projects where I've done this through DEP, see how they do it, but I've been oversizing pumps to a certain degree with VFDs, where you start out at the higher rate, resuspend stuff, and then ramp down to 2 feet per second to save energy. So I don't know how DEP is going to deal with that issue, because it's something new when you oversize a pump based on just scour velocities in the force main.
Okay. I see you, Art, shaking your head furiously.
Yeah, no, Rich, that we see that a lot. People will, you want that ramp up speed. If you just allow the pump to stay at a slow speed all the time, again, it's that washing machine effect. You get that stuff balling up down below, you get a pile of grit just piling up beneath the volute. So you do want to ramp up the speed of that pump, to get that flow out of there. The other factor is, looking, if you have a heavy I&I grit load in a pump station, there are things you can do. It could be the pump design, the type of impeller, recessed impeller, so the stuff theoretically isn't touching the pump, not as efficient. You can get hardened impellers. That's most common that we see. And again, there's aftermarket coatings, things like Belzona and stuff like that people have done, where they know, hey, I'm literally pumping grit, and so you're borrowing from some of the slurry and ag type industries on some of the coatings that you can get. I will say some of those coatings, they can be almost as expensive as the pump. So, really try to quantify exactly what your problem is. I venture to say most solids handling pump impellers, the cast iron that you're using, whether it's hardened or not, typically is going to be good enough for the life cycle of that pump.
Yes, Chris.
As Richard talking about scouring velocity, there was a movement underfoot by Sanks to get rid of air release valves by achieving a scour velocity about 6 feet per second and eliminate the need for air release valves. Have you ever designed anything to eliminate air release valves?
No, I've never tried to get up to the scour velocity of 6 feet per second, because that's kind of problematic. You're starting to really get more head loss. Now, if you're close anyway, because you need to do it, that's fine, then you can. But no, I haven't purposely gone that high. I'm pretty much 3.5, 4. But I agree with Sanks to try to get rid of air release valves, whatever you could do. If you have to, put a pipeline in deeper, do that. I'm trying to think of other options. I've actually specified put force mains at a slope. The larger pipes say you will install this at 1% or whatever, rather than just let the contractor install it with 4 foot of cover, because then you do end up with a lot of up and down on the pipeline. So I tried to do everything to avoid that.
Okay, any other comments on that? Okay, another question from our audience. This is from Keith Edelman, and he asked if there's any chemical preferences for odor control. are there a bunch of different options out there, or one that really, really works? Or is it like the more you pay, the better it works? How's it go? Dale?
Heath, you know the answer to this. It's whatever art represents. No, I can resist.
I'll give the classic answer, Christine. It all depends on what your odor problem is.
I mean, there's a
I will
bunch.
let others answer.
If, like Rich was saying, if you're worried about the downstream receiving manhole, there's different types of iron salts and ferric and things like that you could use. There's proprietary combinations of chemicals that you can use. We see a lot right now, people putting little ozone systems in. I mean, into it. I don't know how well they work. I personally don't have a ton of experience with them in wet wells, but we do see a lot of people, using small ozone generators for odor control.
Dale?
Just one comment on the ozone. I think it's a good technology, and I'm not really that familiar with it either. But say you go that route, every piece of metal in that wet well had better either be stainless steel or really coated well, because it won't be there in about 6 months if it's not. So you got it. There's other things, you decide to do that. That's great. But then it's a domino effect. You have to do something else.
Yeah.
Nothing's easy, Christine, nothing.
Well, and I'm almost wondering, like, there's all these great options. How do you, ideally you're working with, an operator, or I'm sorry, an engineer who's been through all this before and understands sort of step by step. Does it make sense to visit other operations, see what they have in place, and then see what fails, or ask them, okay, what have you struggled with? What's falling apart? Chris, you were shaking your head.
Yeah, that's usually when I make a call to Bob or to Art and say, we've got some operators that need to see exactly what you're talking about. Can you set something up so that these guys can see? And usually that's the best approach I've taken. But I don't know how Rich designs, but usually that's the point where you bring the operators in and let them see what they could potentially get.
Yeah, no, and that makes it's sort of like, test driving a car, checking out a house. Art?
It sounds like you have your next operator roundtable topic, odor control and wet wells, because you could literally go twice as long as this is.
Bob?
The other issue is if you do add odor control, as someone said, it's a domino effect. It will possibly take care of the odor issue. But Art mentioned ferric. We had a situation where they added a ferric solution, and it coated the liner on the flow meter, and the reading of the flow meter went down significantly over a very short period of time to where they had to replace the flow meter. So when you do something one point, it may solve that problem, but create another problem downstream, and that has to be taken into account.
Okay. Yeah, Dale?
One quick thing about chemicals. My first place, again, going back to that, we had odor issues at the pump station, so we tried hydrogen peroxide addition. That worked slightly. Then we used ferrous chloride, and that stuff worked great. The problem was it ate everything black off the force main. Our influent to the treatment plant was black for a month, totally black. And it just so happened within that month, we had our open house for the community come in. Everybody, I said, it usually doesn't look like this. So yeah, because we had EQ tanks, it's all black. The mixed liquor and everything was brown, but the influent was totally black because it ate all that nasty stuff off the inside of the force mains and moved it to the plant.
Chris?
Has anybody ever used potassium permanganate, KMNO4?
I have.
Dale? So does it work, or it doesn't work?
Oh, it works. If it depends what color you want to be that day, because you'll
It turns everything
purple. You look like you look like Barney.
That's awesome.
Everything has a drawback. Remember that.
God, wastewater's tricky. Okay, another question. Two people from the audience pose this, and it's in regards to floats or level transducers. So which is better to sense and control levels in the wet well, floats or transducers? Dale, what do you
Yes.
I see a current trend that a lot of people are going to transducers, and I have to agree. A lot of people will put a transducer and then have float backup in case the transducer fails, then you have float backup. I see a lot of people now putting in 2 transducers instead of floats at all, because floats in general in a pump station are a pain in the butt. They're always going to get grease on them. They always have to be clean. So if you have them there as a backup and you don't use them for 4 years, they now have gigantic gobs of grease on. They don't work anyway. So I see, and there's bubbler systems too. I'm really not familiar with bubbler systems. I know a lot of people like them. A lot of people really, think they work well. And I think it's, again, it all depends. If you have used bubbler systems and they work good for you, stick with it. But I do see a tend to level transducers away from floats.
Okay, Art?
Yeah, I think tying into the transducer line of thinking, you see it more often because you need that if you're using VFDs, you need to have some type of 4 to 20 signal to control the speed of the pump motor. So I would say probably 90% of the pump stations that are designed have transducers, float backups. There are other level sensing devices out there. I personally will not recommend like the radar type, only because there's a lot of room for error. One of the other comments was smaller wet wells. The problem with the radar, you get interferences and things like that. It's not necessarily, it's not monitoring the level in a big water tank where there's no obstructions, but in a wet well environment, be aware of your surroundings. But there's other things like capacitance probes and things like that people can use. Dale mentioned bubblers, but I think it's fair to say transducer is where most of the industry is.
Okay. Yeah. Bob, what have you been seeing?
Although I've seen a little bit of a trend, Art, into radar again. The radar, the ultrasonic, was frowned upon years ago. We went, I think, more to the submersible transducer. I agree with Dale, floats can be problematic at best. But last several jobs I've seen, they're going back to the radar, and they're saying they're solving the problem of the interference. Obviously, it's got to be strategically placed in the wet well. But also the problem with, I think more so with the ultrasonic, was the foam that can accumulate on top of the surface and give you a false level rating. But the last couple of jobs I've seen are radar.
Craig Conrad.
I'm not sure why, but
Craig Conrad, one of the participants, and if it's the Craig Conrad I know, Fleetwood Borough, but that's Craig, and they just did the same thing. He just put that in as a comment.
Yeah, so he said he's a radar level sensor with a float backup, and it works terrific. That's good to know. Dale, did you have a comment?
Nope, no comment.
No? Okay. And just a reminder to our audience, looks like we've got about 5 minutes left. So we've got a few more Q&As that I'd love to cover. And Craig says, hi, Chris, it's me. I'm not sure if this was covered or not. Heath Edelman had asked, does anyone install trash baskets anymore? And if one's being removed, do people convert to grinders? Is a trash basket the same as a screen, or is it different? Rich?
Well, it's kind of like a screen. I've been using that as with a rail mount of replacement for putting in a muffin monster. So it's kind of like a basket with.
Oh, wait. Did you just say muffin monster?
Yeah, you've never heard that term?
What's that?
It's a grinder. I'm sorry. That's a proprietary name.
Yeah, it should be called a twin shaft grinder, Rich. We're not having preferences here.
It's similar to Coca-Cola or Xerox in our industry. Every grinder now is called. Hey, do you guys have a muffin monster?
No, Chris, we have a Taskmaster.
I'm sorry, Rich, what were you saying?
You watch Dirty Jobs. Dirty Jobs had a muffin monster out in San Francisco, which the guy had to maintain.
You want to get dope slapped by an operator? Give him a trash basket.
Yeah, that's what I was gonna say. The trash basket is that thing you see sitting outside of the wet well at every pump station.
Okay, good to know.
No,
Rich,
to maintain it.
Well, we provide that like as a screening device just to keep DEP happy. It's meant to be removed for the grinder, for the chopper or grinder pump. So it's not anything that we want anybody to use. We just put it in there to keep DEP happy. It's like a screenings basket.
Little secret. Okay. Any other comments about that? Okay. Comment from Mark Manizak from Entech. He says the design of pump stations should also consider flotation, meaning the water table. And any have any of you guys run into problems where you stick a pump station in the ground and it floats, it pops out of the ground. Anyone ever see that happen? Art?
Yeah, it's,
I did see that, but it wasn't a concrete wet well. It was one of those fiberglass wet wells that the contractor just didn't ballast around it. And first it was at Harrisburg, and all of a sudden this 15-foot deep wet well was sticking 5 feet out of the ground. It's pretty neat, but it wasn't the way it was supposed to be.
Dale?
This wasn't a pump station, but up at my where my hunting cabin is, I watched 5 guys dig a hole and bury a 500-gallon septic tank behind their cabin, and we all left and came back. And it rained during the week. We all came back, and it was sitting right there on top of the ground when we came back after they buried it because they didn't put any water in it. So it can happen very easily.
yeah.
So essentially, to get around that, you either need to have stuff in it the whole time, or Art, you said something about ballast around the outside, or what do you do?
Yeah, so your structural design, whoever's doing your structural design, will make sure that it's held in place.
Okay.
Pour
It's
concrete
definitely-
and
It's
and
definitely
tie
the
the concrete.
responsibility of the structural engineer, not the process engineer. It's
Yeah.
structural.
Please don't fill your wet well with concrete with the pumps in it.
Okay, excellent. Well, I see we're up against the clock. It's 3:15. So for my audience, I want to remind you guys, if you enjoyed today's roundtable, we've got more coming up. Tuesday, April 22nd. This one's at noon, and it's Wonder Women, surviving and thriving in the water and wastewater industry. Cannot wait for that one. And men are welcome. We're looking at ways that we can communicate better with each other and all be more productive. Also working on several other roundtables. Why do you want to do a comprehensive environmental regulatory audit? That one we actually may have before April 22nd. So we're still working on the timing of that. We'll do a water regulatory update, beer with an engineer. Heath, you're asking about fog. We're planning on a clearing up your fog program. So it'll be a lot of fun. If you want to check out upcoming roundtables or see videos of past ones, go to our website, www.entecheng.com. The menu along the top, look for resources, and then the drop-down menu, there's one for roundtables, and you can learn more. So huge thank you to my panel, Chris Hannum, Dale Miller, Rich Harrison. I love hearing your stories and your experiences. From Riordan, Art, you were wonderful, just as we expected. And from JT Seeley, Bob, excellent information, really good stories. I loved it. So I'm going to leave this up for a moment. If anyone wants to get PDH certificates or the operator CEHs, there is my email address. Send me an email. Let me know what you're interested in getting. And I want to, let me just double check. Are there any other questions from the audience? Ed Petrosky mentions that he's in the process of reinstalling a 125,000 gallon tank that floated on Christmas. So I don't know any details about that, and I'm hoping it was a personal tank and not one for a client. So to round things out, I'm going to reach out to my panel and curious, anyone else have any questions or any comments, any words of wisdom to share with our audience before we sign off? Okay, so we covered everything. Dale, yeah, Dale, go ahead.
Just if you're an operator out there and they're doing upgrades in your system, please talk to your engineer. Tell them what you experienced. Tell them what you know. Tell them what you've seen. Tell them what called you out at 2 o'clock in the morning, and hopefully they can help you. But they have to know to help you. So you don't be afraid to talk to them.
And borrowing on that line, for the engineers, Rich, Chris, I know you guys know this, but for the rest of the engineers at Entech or whoever else might be listening, listen to your operators, please, because it may look good on paper. You may have the most efficient, best selection, but if it's not designed correctly, you're not maintaining that environment, the operator is going to hate you for the rest of your life. So I know it's one of your roundtables, Christine, keep that dialogue open. Absolutely.
Yeah. Okay, any other comments, suggestions? Okay, well, a reminder to the attendees, first of all, thank you so much. We loved having you out there. You will see a short 3-question survey. It's completely anonymous. It helps us make these even better for you guys in the future. You take 20 seconds to fill it out. When you sign off, I'd appreciate it. Huge thank you to my panelists. You're all excellent and so interesting. Who knew like crap could be so much fun? This is great. I learned a lot, and I know our audience did too. So I always say magical things happen when you bring together passionate people. And my God, you guys are passionate about this. So thank you. Thank you, everyone. And we will see you soon. Bye, everybody.
See ya.